Introduction. Sieve analysis is performed to determine the gradation or grain size distribution of different particle sizes of coarse grained soil, sand, or coarser portion of a soil containing both coarse sand and silt and fine silt and clay particles. A sieve analysis consists of shaking the soil through a stack of wire screens with openings of known sizes. The definition of particle diameter for a sieve test is therefore the side dimension of a square hole. It should be noted that sieve analysis does not give any idea about the shape of the particles. Sieves are made of woven wires with square openings. Table 4 gives a list of US standard sieve numbers with the corresponding size of openings. For all practical purposes, has 200 sieve is the sieve with the smallest opening that should be used for the test. The sieves that are commonly used in the test have diameter of 8 inch, 203 mm. Table 3.1 shows you sieve number and openings. Actually, for the purpose of gradation of soils, there may be one of the following three tests. 1. Sieve analysis, applicable when the soil contains mainly sand and large particles. 2. Hydrometer analysis, applicable when the soil is fine-grained or silt and clay particles. 3. Combined analysis, that is both sieve and hydrometer analysis, applicable when the soil contains sizable portion of both fine and coarse fraction. From sieve analysis, information about grain size distribution is obtained. Besides the gradation curve, other parameters namely uniformity coefficient Cu, coefficient of curvature Cc are determined, and all these information are used for classification. It is pointed here that FM fineness modulus is determined from sieve analysis done on fine and coarse aggregates as you have done in concrete laboratory. However, FM has almost no meaning and use in geotechnical interpretation and understanding of soil behavior as a foundation material. Scope of the test. This test is performed to determine the percentage of different grain size contained within soil. The mechanical or sieve analysis is performed to determine the distribution of the coarser, larger sized particles, and the hydrometer method is used to determine the distribution of the finer particles. Significance. The distribution of different grain sizes affect the engineering properties of the soil. Grain size analysis provides the grain size distribution and it is required in classifying the soil. Standard reference ASTM D42263, standard test method for particle size analysis of soils. Apparatus. ASTM sieve has 4, has 8, has 16, has 30, has 50, has 100, has 200, pan, lid, brush, container, spoon, bowl, balance, sieve shaker. Test procedure. 1. Write down the weight of each sieve as well as the bottom pan to be used in the analysis. 2. Record the weight of the given dry soil sample. 3. Make sure that all the sieves are clean and assemble them in ascending order of sieve numbers. Has 4 sieve at top and has 200 sieve at bottom. Place the pan below has 200 sieve. Carefully pour the soil sample into the top sieve and place the cap over it. 4. Place the sieve stack in the mechanical shaker and shake for 10 minutes. 5. Remove the stack from the shaker and carefully weigh and record the weight of each sieve with its retained soil. In addition, remember to weigh and record the weight of the bottom pan with its retained fine soil. Data analysis. 1. Obtain the mass of soil retained on each sieve by subtracting the weight of the empty sieve from the mass of the sieve plus retained soil and record this mass as weight retained on the data sheet. The sum of these retained masses should be approximately equals the initial mass of the soil sample. A loss of more than 2% is unsatisfactory. 2. Calculate the percent retained on each sieve by dividing the weight retained on each sieve by the original sample mass. 3. Calculate the percent passing or percent finer by starting with 100% and subtracting the percent written on each sieve as a cumulative procedure. 4. Make a semi-logarithmic plot of grain size versus percent finer. 5. Compute uniformity coefficient Cu and coefficient of gradation Cj for the soil. Cu is equal to D60 by D10 and Cj is equal to D30 square divided by D60 into D10. Figure 3.1a. Clean all sieves before test. 6b. Weight all sieves. C. Serially set all sieves according to their opening size. D. After pouring the soil, place it to sieve shaker and shake 10 minutes. E. Weight all sieve with contained soil.